Hi, my name is Eva, and this is my lab report for the second lab of Physics 2, where I was looking at the magnetic field of a bar magnet. So overall, the goal of this lab is to use a bar magnet to measure how distance depends on the magnetic field from a bar magnet, and then to calculate the distance dependence using equations that I will show eventually for on and off axis magnetic fields from the Biot-Savart law. And I did this using glowscript and Excel for when I tested this in real life with like actual magnets instead of just code. And then I compared these values uh, of the predicted values from glowscript of distance dependence to the actual values that I found when I tested it like myself. So there are a couple of physics principles that go into this. First of all, the magnetic field, which is the force experienced by charged particles, currents, and magnetic materials when they are around a magnetic field, which is created by electric currents or moving charges. And magnetic field lines form closed loops, and this shows the magnitude and direction of the magnetic force at different spots. And another concept that is important for this lab is superposition, which is that the magnetic field at any time can be, or at any point can be found by adding up like smaller pieces. And this can be used to calculate difficult to understand magnetic field configurations because they're broken up into like more simple parts. There are a couple equations that I used for this lab, and I put them all into an Excel sheet to make my computations a bit more easy to understand, and this was through the spreadsheet provided. So these are the results that I got from glowscript and then also from my own experiments. So what I found is that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. And as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. And I also graphed these results, which can be seen below, and I'll be showing the rest of the spreadsheet eventually. Then on the right, I provided my calculations that I got from glowscript, which I will also go into later in the lab. So overall, for the experiment, I looked at the system as the magnetometer and the bar magnet, and the surroundings was basically just nothing, but it was anything that was not the magnetometer and the bar magnet. And initially, I put my phone at the true east-west axis on the ground and used a magnetometer app to measure the bar's magnetic field. For on axis, I measured the distance between the bar magnet and the magnetometer, and then off axis, I measured the y direction of the Earth's magnetic field and used it to move the magnetometer to that distance. And for this, I assumed that the bar magnet is a perfect dipole and that no other forces besides the bar magnet were acting on the magnetometer, which in actual like real life is probably not the case. Then this is the data that I got from Excel from all of these computations. And I basically, through the equations that I showed earlier, I found dperp, b Earth, in different axes, distance, and then I used all of this to eventually calculate b net, which I can compare to what I got from my glowscript model, which is shown here. And through this, I got slightly different numbers for each of the quantities shown in this box at the bottom of the screen. They were slightly different than what I found when I measured this in real life, which I'll go into why that could be later. So basically, the real life calculations were about double what the model was. And there were a couple discrepancies because the forces acting on the magnetometer other than the bar magnet were probably not zero, and this was not accounted for in the glowscript model. And some sources of error could be rounding, phone data that could have been not accurate, as well as human error. And some questions to consider for if I wanted to do this again, maybe was what if I had oriented my setup to compensate for the magnetic north? And this magnetic north helps to make sure that the Earth's magnetic field contributes consistently to my measurements. And if the meter stick were placed at an intermediate angle instead, the Earth's magnetic field would affect X and Y. And the contribution would depend on the angle how it deviates from the true north. And I could have repeated this experiment with two identical magnets stuck end to end, which would change the field configuration, and the combined magnets would generate a stronger magnetic field, especially in the region between them. And I would probably see higher magnetic field measurements in that area, potentially close to double what I'd see with just one bar magnet. And that's all. Thank you.